Okay, I'm going to start making some more videos to help you if you're having trouble with doing some of these calculations or working through some of these problems. So we just started talking about stoichiometry as part of our chemical reactions unit. And stoichiometry, if we remember, is just a very fancy way of saying we're going to count the atoms or count the elements or count the molecules that are there. Okay? The most important thing about stoichiometry is that we always need to start with a balanced equation. So whatever we're doing, we need to make sure it's balanced. And it's probably a good idea to always to not assume that the equation is balanced, to really check. Because if you start with an unbalanced equation, your final answer is going to be incorrect. And so these are mole problems. So that means that we start, we're given information in moles, and we want an answer that's also in moles as well. So let's look at number one. So number one says, how many moles of potassium oxide will be formed when 1.52 moles of potassium reacts with oxygen according to the following reaction? So we're given our reaction here. This means that we have 4 moles of potassium plus 1 mole of diatomic oxygen makes 2 moles of potassium oxide. The first thing you should really do here is to check to make sure it's balanced, if it makes sense. So we got 4 potassium, 2 multiplied by 2, that gives us 4. We got 2 oxygens here, 2 oxygens here. So that's perfectly balanced. So that is the first step to ensuring that you get a correct answer at the end, is to make sure that your equation is balanced. All right, the next thing, how these problems work, and the best way to set them up is you always start from what you have, and you go towards what you want. So what do I mean? So the question tells you, this gives you what you have right here. You have 1.52 moles of potassium. Okay? I want to know, this is what I want. I want to know how many moles of potassium oxide will be made. So when I set this question up, I set it up where I go from what I have working to what I want. So to start that out, so I put what I have. So what do I have? I've got 1.52 moles. And just MOL is fine to write as a short form for moles of K. And I write it all down because we really need to make sure that everything cancels out. So put it down just so you remember what it is. Okay? When we're doing these questions, right, it's all a fixed ratio. The coefficients tell you how many moles, and the moles set up a fixed ratio among the different parts of the chemical reaction. So since it's a fixed ratio, I can sort of substitute in whatever numbers I want and get an answer at the end. So 1.25 moles of potassium. Now, what do I want? I want to find out moles of potassium oxide. And on the bottom here, I'm going to want this to cancel out potassium, so I'm going to put it on the bottom so that my answer when I'm left is with moles of potassium oxide. So, what is the ratio here? Well, potassium oxide, 2 moles to 4 moles, which is the same thing as 1/2. Okay? So, on your calculator, type in 1.52, multiply that by 2, and divide it by 4, and that'll give you, so that, if you want to make sure that cancels out, so this tells us what our answer is. Our answer is going to be 0.76 moles of potassium oxide. Okay? Okay, I'm going to do one more with you because this needs to be handed in, but I want to make sure everybody's got a good shot at it. Okay, so number 2 says, how many moles of copper are needed to react with sulfur to produce 1.25 moles of copper 1 sulfide according to the following reaction? Okay. So it's a good first step. Let's make sure our chemical equation is balanced. All right. So I have 2 moles of copper, 2 of copper. Good. 1 of sulfur, 1 of sulfur. That's fine. That's balanced. We're all right. Now let's indicate, what do we have? Well, it's telling us I've got 0.25 moles of copper 1 sulfide. So that's what I have. And then it's telling me here how many moles of copper. So this is what I want to find. This is what I want, right? And when we set it up, we always go from what we have to what we want. What we have to what we want. All right, so when I'm writing this, I'm going to start. Right, I'm just going to put this down so what I remember. I'm going to start with what I have, and I'm going to go to what I want. So I have 0.25 moles of Cu2S. I'll multiply it by some sort of ratio. Now, what do I want? So I want to know how many moles of copper. And then on the bottom, I need it to cancel out, so I'm going to put that on the bottom. So how many, the ratio, I've got 2, and I've got 1. Okay? That will cancel out. And then just, all we have to do is multiply 0.25, multiply by 2, and that gives us 0.5 moles of Cu, copper. Okay? The other ones in the bottom, look, we're going to have to, for this one here, you do this one on your own because you have to hand this in. I hope this gives you the basic logic of how to do these questions. So for this one, it's going to have to balance it. It's left open for you to balance. On the back, you need to balance this one and work it out. For number 4. Number 5, you are going to have to write the word equation and balance it and then solve. See, these are great kind of questions to ask because they assess your ability to write equations, your ability to balance ionic charges, your ability to balance chemical equations. All of that is very much tested there. And your ability to solve these stoichiometric problems as well. And question number 6 is similar to that as well. Okay? So if you have any questions, please let me know, and I can sit down with you after school on Thursdays, or I can join you in study hall at 7 o'clock. All right, good luck. See you soon.